Hello dear students, welcome back in the video lecture series. Dear students, we have started the discussion of nitrogen group elements, and in that we have completed the different nitrides, different classes and the details of boron nitrides. Okay. Now our today's topic is oxidation states of nitrogen and their interconversion. Okay. So, we know that the nitrogen is existing in the nature in a very inert form, that is dinitrogen gas, N2 gas, and we have also seen how that N2 gas is activated, that is nitrogen activation, to the active form, that is ammonia, by a well known Haber process. By reaction of N2 with hydrogen gas in the presence of ion catalyst, that is in Haber process, we have converted that dinitrogen gas into a active ammonia gas, which is widely used for the production of fertilizers and different other chemicals such as nitric acid, etc. Here the nitrogen is showing a varying different types of oxidation states, and these are ranging from +5, +4, +3, +2, +1, 0, -1, -2 and -3. So, nitrogen is able to form a large number of different types of inorganic compounds, and that are due to the possibility of different oxidation states of this nitrogen atom. Okay. And we have to consider, we have to study these nitrogen oxides. Okay. So, when nitrogen is combining with oxygen in different forms, in different stoichiometry, the resulting compounds, that is nitrogen oxides, are, or we can also call them as oxides of nitrogen, are having different structures with different oxidation states. Okay. So, let us look here the different oxidation states of this nitrogen atom, then the name of the resulting oxide of nitrogen, its formula and its structure. Okay. So, in your examination, the structures of these oxides of nitrogens or oxoanions of nitrogens may be asked. Okay. What will be their oxidation state, then what is the name of that structure, that are also important. Okay. So, the first one is, so we will prepare a table, and that prepare is consisting of oxidation number, formula, name of that structure, name of that compound and the structure of that compound. Okay. So, +1, oxidation state is +1. So, the formula is N2O, formula is N2O. Okay. Formula is N2O. Here the oxidation state of nitrogen is +1. The name is nitrous oxide. The name is nitrous oxide, and the structure is NO. Okay. Here this is a structure of N2O, that is nitrous acid. Okay. So, there is a presence of one positive charge on nitrogen and one negative charge on nitrogen, which cancels each other, and we may write this as a neutral compound, that is N2O, or you may write this resonating form of this compound like this. Okay. So, N double bond O. So, this is also a one of the positive charge on nitrogen and negative charge on nitrogen. This is also one of the resonating form of this nitrous oxide N2O. Okay. So, both of these structures are correct. Okay. Then this is the first oxide of nitrogen. Then the second one is the nitrogen is showing +2 oxidation state and the compound is NO. The compound is NO. It is called nitric oxide. It is called nitric oxide. Okay. It is called the nitric oxide, where oxygen is having -2 and nitrogen is present in +2 oxidation state. Okay. The structure is very simple. Okay. This is the structure of nitric oxide NO. Okay. Then the nitrogen which exists in +3 oxidation state is N2O3. It is N2O3. Okay. The name of the compound is dinitrogen trioxide. Dinitrogen trioxide. Dinitrogen trioxide. Okay. And the structure is N2O3. Okay. N2O3, 1, 2, 3. Okay. So, the valency of this nitrogen is correct, 1, 2, 3. Then for this oxygen 1, 2, oxygen 1, 2, this oxygen is having only 1. So, this is having minus charge and this nitrogen having 4 valency. So, it is having a positive charge, and as a whole it is a neutral molecule. So, this plus positive mono positive charge is get neutralized by mono negative charge. Okay. So, this is the structure of N2O3, that is dinitrogen trioxide. In this case nitrogen is existing in +3 oxidation state. Then the next compound is NO2. Next compound is NO2, or it is also called as N2O4. NO2 or N2O4. It is nitrogen dioxide. Nitrogen dioxide. Nitrogen dioxide or dinitrogen tetroxide. Dinitrogen tetroxide. Di means 2, tetra means 4. So, nitrogen atoms are present in 2 number and oxygen atoms are present in 4 number. So, dinitrogen tetraoxide. Okay. This is the name of this compound, and the structure is NO2. It is bent structure. Okay. So, this is the bent structure and the bond angle is this is another, this compound is existing. This is the dimer of dinitrogen tetroxide, is the dimer of this NO2, and it is forming a different type of compound. Okay. So, bond angle is 134 degree. Okay. Again this NO2 is existing in +4 oxidation state and the compound is nitrogen dioxide. The compound is the structure is bent structure having the bond angle between 2 oxygen and 1 nitrogen atom is 134. Then the dimer of this NO2 is called N2O4. N2O4, it is called dinitrogen tetroxide. Dinitrogen tetroxide. Okay. And the structure is like this. Okay. So, the 2 nitrogen atoms are joined together by a single covalent bond, and each nitrogen atom is having 2 oxygen atoms. One is bonded, one is doubly bonded, one is singly bonded. Okay. So, 1, 2, 3, 4. Each nitrogen atom is tetravalent here. So, this is carrying minus charge on oxygen atom and there is 1 positive charge on nitrogen atom. So, as a whole 2 positive and 2 negative charges are there. So, as a whole this molecule is also neutral, and the last compound of this oxide of nitrogen is N2O5. N2O5, it is called dinitrogen pentoxide. Dinitrogen pentoxide. Okay. And the structure is very simple, only add central oxygen atom in this structure. So, you will get the resulting structure O, then double bond, O, single bond, O. Okay. So, again the case is similar to that of N2O4. This nitrogen is carrying plus charge and oxygen atoms are carrying negative charges. Okay. 2 positive neutralizes 2 negative charges. So, this is called as N2O5 dinitrogen pentoxide. This compound, that is dinitrogen pentoxide, is also called as anhydride of nitric acid. We know that the structure or formula of nitric acid is HNO3, and this compound is called as anhydride of nitric acid, okay, dinitrogen pentoxide. Okay. So, this is all about the different oxidation states of nitrogen in which oxides of nitrogen can be formed. Okay. So, these are the formulae names and these are the structures. Okay. You have to remember all these data, this table. This is very simple. When you have a practice to write and remember this table, then you will be recall all these things. Okay. Then we have to consider all these interconversion of these oxidation states of nitrogen. So, interconversion means how this +5 oxidation state of nitrogen is get converted to +4, then 0 oxidation state of 0 oxidation state of nitrogen, that is N2 gas is converted to -3, then all these things. Okay. So, interconversion of these oxidation states means it is nothing but reactions of these oxides of nitrogen and their compounds to other compounds. Okay. So, that reactions, inorganic reactions we have to study here. Okay. So, first is nitrogen 5 oxides and oxyanions. Nitrogen 5 oxides and oxyanions. We know that nitrogen 5 oxides and oxyanions means how that nitrogen with oxidation state 5 or oxidation number 5 are interconverted into other oxidation states of nitrogen gas. Okay. So, we will start with a nitrogen atom with 0 oxidation state. Okay. And we know that it is nothing but a N2 molecule, that is N2 molecule in which nitrogen is existing in 0 oxidation state. Okay. The structure of nitrogen is N2 is N triple bond N, in which both nitrogen atoms are bonded to each other by triple bond and N triple bond is there, and in that both nitrogen are existing in 0 oxidation state. So, this is we call it as a inactive form, or inactive means it is we have to convert, we have to activate this N2, inactive N2 by a Haber process, and when this N2 gas, that is dinitrogen gas, it reacts with hydrogen gas in presence of an ion catalyst. We know that this process is known as Haber process, in which there is activation of 0 oxidation state of nitrogen, okay, to -3 state of oxidation state, -3 oxidation state of nitrogen, that is ammonia. Okay. So, twice NH3, that is ammonia gas is produced, and in this ammonia the nitrogen is existing in -3 oxidation state. It may be written as in Roman numbers. Okay. So, this is the you can write this or either this. Okay. So, this in this ammonia, this nitrogen atom is present in -3 oxidation state. So, this is the interconversion. How this interconversion, see here, how this nitrogen with 0 oxidation state is get converted to -3 oxidation state of ammonia. Okay. Then the next reaction is oxidation of this ammonia that produced in the first step, okay, to NO2. Okay. So, means we are doing here oxidation of ammonia, and we know that NO2, where is NO2? NO2 is existing in +4 oxidation state, means this is the reaction in which -3 oxidation state of nitrogen is get converted to +4 oxidation state. Okay. So, NH3 plus O2 is get converted to, both are gases in which NH3 is present in -3 oxidation state and NO2 is formed, plus water is the side product. Okay. And in NO2 nitrogen is in +4 oxidation state. Okay. So, for balancing of chemical reaction, the reaction is 4 ammonia and 7 oxygen gas. Okay. So, 2 into 2, 4 nitrogen atoms are there. So, 4 hydrogen, 4 3s are 12. So, 6 water molecule will be removed. Then oxygen, 7 2s are 14 on the LHS, 4 2s are 8 and 6, 8 plus 6, 14. Okay. So, this is the balanced chemical reaction between ammonia, oxygen to form nitrogen dioxide. Okay. So, what we have to study here? This is a very simple reaction that can be studied in 11th or 12th standard, but what is important here from the PG point of view, we have to study this reaction in respect of interconversion of this -3 oxidation state of nitrogen to +4 oxidation state of nitrogen. Okay. So, it is ammonia to NO2. Okay. Then this NO2, that is nitrogen dioxide, is get disproportionate. So, the next reaction is disproportionation of NO2 to NO and HNO3. So, HNO3 is nitric acid and NO is nitric oxide. Okay. So, we have to see this reaction NO2, this NO2 is get react with so NO3 is in +4 oxidation state. Okay. This is also gas, this is also it may be gas or in gas means steam and it may be or liquid. Okay. So, what will be the reaction? HNO3 plus NO. Okay. Now, balance the chemical reaction, twice NO, okay, 2 nitrogen, 1 nitrogen, 3, then oxygen, 3 2s are 6, 3 here 3 and 1, 3 plus 1, 3 plus 2, 3 plus 2, 5, hydrogen 2. So, here 2 hydrogen, twice HNO3. The balanced chemical reaction is twice HNO3 plus NO, twice HNO3 plus NO. Okay. And in this case HNO3 is in +5 oxidation state, nitrogen is in +5 oxidation state, and this NO is having, we know that NO, what is NO? +2. Okay. So, here this is the interconversion of +4 oxidation state of nitrogen, that is NO2 gas, to +5 and +2, means this reaction is called as disproportionation reaction. Okay. Then next reaction is the decomposition of nitric acid, to NO2, decomposition of nitric acid to NO2 means what? When we keep the nitric acid in bottles, that nitric acid get decomposed into a NO2 gas. Okay. And the reaction is very simple, that is 4HNO3, that is nitric acid which is in +4 oxidation state. Okay. It is get decomposed into NO2, okay, plus HNO2 plus water plus oxygen. Okay. So, water is, oxygen is gas, this is liquid, and NO2 is also gas. Okay. So, nitric acid is in exist in +5 oxidation state, then this oxygen is gas, then water, and this NO2. Okay. And this NO2 is in +4 oxidation state. Okay. NO2 is in +4 oxidation state. So, here nitric acid which is in +5 oxidation state is get converted to +4 oxidation state, that is NO2. Okay. Then the next reaction is aqua regia. The next reaction is formation of aqua regia. We know that what is aqua regia? Aqua regia is nothing but a mixture of nitric acid and hydrochloric acid in 1:3 proportion. Okay. So, a mixture of 1:3 proportion, mixture of concentrated nitric acid and concentrated hydrochloric acid. Okay. That is when HNO3 plus thrice HCl, okay, both are concentrated, okay, liquid, when they are mixing together, then there is a formation of orange color NOCl, orange colored NOCl fumes are formed, okay. NOCl fumes are formed, they are called as nitrosyl chloride, okay. These are orange fumes, and this mixture is used in the qualitative analysis, okay. We are familiar with this mixture, it is known as aqua regia, it is known as aqua regia. This mixture is called as aqua regia. It is a Roman word, the meaning of this Roman word aqua regia is royal water. Regia means royal, aqua means water, it is called as royal water. Why it is called royal water? Because this mixture is able to dissolve the noble elements such as gold and platinum, okay. Why it is called as noble elements? Because they are acting as very inert element, okay, in the atmosphere. There is no any action of moisture, air, nitrogen, different gases present in the atmosphere. These gases are unable to react with these noble elements, that is precious elements, that is gold and platinum, okay. So, that is why this gold is soluble in this mixture, which is known as aqua regia, and hence the alchemist are the group of scientists which are involved in the conversion of all elements into gold, okay. Such chemists are known as alchemists, okay, and they have prepared this first time aqua regia, okay. So, come to the point. So, this HNO3 and HCl concentrated acids in 1:3 proportion, okay, they are forming this nitrosyl chloride, and the balance reaction is there is a formation of Cl2 gas, okay, Cl2 gas, NO and water H2O, okay. So, 2 hydrogen atoms, 4 hydrogen atoms, oxygen 3, oxygen 2 and 1 3, 1 nitrogen, Cl, 3 Cl, 1 2 C, okay. So, this is the balance reaction, nitric acid and HCl combination in 1:3 proportion, there is a formation of nitrosyl chloride, this is the orange, these are giving orange fumes, okay, and a chlorine gas with side product water, okay. So, what is important here? This reaction, that is nitric acid and combination of both nitric acid and hydrochloric acid, okay. Then the next reaction is N2O5, formation of N2O5, okay. So, this we have already told that this N2O5 is called dinitrogen pentoxide, and it is the anhydride of nitric acid, okay. N2O5, it is called anhydride of nitric acid, okay. How it is prepared? Anhydride of nitric acid, how it is prepared? It is prepared by the reaction of nitric acid, dehydration of nitric acid by P4O10, that is dimer of phosphorus pentoxide, dimer of phosphorus pentoxide P4O10, okay. The actual structure of this N2O5, or we may call it as a correct structure, it is existing in the ionic form NO2 plus and NO3 minus, NO2 plus and NO3 minus, N2O5, 3 plus 2 5, positive negative charge get neutralized to each other. This is the correct structure of this N2O5, okay. The correct formula we can say NO2 plus and NO3 minus, okay. So, the preparation of this N2O5 can be done by dehydration reaction of concentrated nitric acid, that is HNO3, okay. So, when HNO3 Okay. HNO3 liquid when reacts with P4O10. Okay. So, this is a dehydrating agent, strong dehydrating agent is there, okay, and it gives N2O5. It is giving N2O5. Okay. For the balancing of reaction, we have 4 HNO3 and P4O10 only. It is solid. It is only 1. Okay. So, 4 N2O5 molecules, 2 N2O5 plus 4 HPO3, which is in liquid state. Okay. So, this nitric acid is get reacting with dehydrating agent P4O10, it is get converted to 4 molecules of N2O5, that is anhydride of nitric acid, that is nitrogen pentoxide will be prepared. Okay. And this nitrogen pentoxide is a strong oxidizing agent, and hence it is used to oxidize the sodium metal. It is oxidized to use sodium metal N2O5 plus Na, okay, and this get converted to sodium nitrite, NaNO3. So, anhydrous sodium nitrate will be formed, anhydrous sodium nitrite. Okay. So, N2O5 and the side product is NO2, 2 nitrogen atoms, 1 2, then oxygen atoms 5, 3 plus 2 5, and 1 sodium atom. Okay. So, this is a simple reaction. N2O5 when reacts with sodium metal, strong oxidizing agents, it oxidizes sodium metal to anhydrous nitrate, sodium nitrate, TRATE, sodium nitrate, that is NaNO3. Okay. And hence this is the reaction of oxidation of N2O5 to sodium nitrate, that is NaNO3. Okay. So, these are the reactions of oxides of nitrogen to other oxides of nitrogen. That is, in short, we can say that these are the interconversion of oxidation states, different oxidation states of nitrogen. Okay. Hence, this is the first part or first lecture of this interconversion of oxides. In the remaining or in the next lecture, we will see the remaining part of this interconversion of oxides and other forms of oxides. Okay. So, thanks for watching this video. Have a nice day.